So with this question here, the first part wants us just to do a straight integral. Now we know that the question is about y equals 1 on root x. We've also been told that each rectangle has a width of 1. Anyway, the first part is just saying what's the integral from n up to 2n of 1 on root x dx. So that's a straight integration and substitute in the numbers. Now some people would prefer that instead of being written as dx on root x, they'd prefer that it was written from n to 2n of 1 on root x dx, but it's the same question. And even more, they probably prefer that it looked like x to the minus a half dx rather than 1 on root x, because then it's easier to integrate. So they're just going to say, well, I add 1 onto the power and get x to the half, and of course I need to divide by the half as well, because then I'll end up with x to the minus a half when I differentiate that. So in the end, they end up with 2 and root x, x to the half is root x. When they've done it all, they get 2 root x, and that's from n to 2n. So they substitute in and get 2 root 2n minus 2 root n, which is 2 root 2's root n's minus 2 root n's. So you can see you can pull 2 root n out, and you have a root 2 minus 1. So the first question's no big deal. That works out pretty easily. But what do they want us to now do with that? We've worked out the integral from n to 2n. That's the actual area under the curve from n to 2n. The question's going to be involving some rectangle approximations, like upper rectangle sums, which is bigger than the actual area, and lower rectangle sums, just smaller than the actual area. So let's have a look what question part 2 wants. Let Sn equal 1 on root n plus 1 plus 1 on root n plus 2, all the way up to 1 on root 2n. So I'll just colour in what I believe that they're saying here. They're saying this height here that I'm colouring is 1 on root n plus 1, because the curve is y equals 1 on root x. So if you put n plus 1 in that height is 1 on root n plus 1. So that's the first number. And if you times that by 1, because they told us the width of these was each 1, you get that area there of that lower rectangle for that first term there. And then 1 on root n plus 2 will just be, well, it's that height for 1 on root n plus 2 times 1 across, because it's got a width of 1. So you get that area there, and so on all the way along until you get to the last one, which is 1 on root 2n, which is this one here, and that's times by 1 to be the area of that rectangle. So basically they're saying it's the lower rectangle sum. That's what S is. Sn is the lower rectangle sum. Okay, so having identified what that is, it's probably a bit easier then to work out what this next inequality is all about. And that's what we're going to spend some time doing. We've got to show that the lower rectangle sum, which is in the middle, is less than 2 root n root 2 minus 1, which we just found. The actual area, well, yes, the lower rectangles are less than the actual area of under that curve from n to 2n, so that should be fine. But then the left-hand part, it's not the upper rectangles that they've got there. It's some other expression. And what they're doing is considering, for that next part, they're considering this rectangle up here. They're taking that, which is like the upper rectangle minus the lower rectangle of that strip, and it leaves you with that blue piece. And then for the next strip, the upper rectangle minus the lower rectangle will be that blue piece. And the next strip, the upper rectangle minus the lower. So they're thinking about the upper rectangle minus the lower rectangle. But more than that, they're saying, what if we found half of that value? And I'll show you that diagonally. What if we found the upper rectangle minus the lower rectangle and worked out this area in here, right? What if we took that and we subtracted that away from the actual area? So that purple bit is going to be subtracted away from the actual area. What would that give us? Well, let's think about that. The purple bit under that purple line, that's more than the difference between the lower rectangle and the actual area. I'll colour in what I mean in yellow here for a tick. This bit here, under here, the difference between the actual area and the lower rectangle, that's smaller than the difference between the purple line there, area, triangle that I'll just make. It's this and the lower rectangle. So what does that mean? Well, if we subtract from the actual area, if we subtract this purple rectangle in this particular strip, right, if we subtract that away from the actual area, we're going to get down below the green stuff that's underneath it. Or I can put this another way. If we had just taken this yellow bit that I'm colouring in and we subtract it from the actual area under the curve in this strip, we'll get the green piece, we'll get the lower rectangle. So if we take in a particular strip, we have that's what the curve looks like. If we take this extra bit here that's above the actual area, if we subtract that from the area of the whole strip, we'll end up with what I'm colouring in green. The whole strip area minus that little bit would be what's in green. I'll draw that up in so that you can see what I mean. The whole strip minus that bit is equal to the lower rectangle. Does that? I hope that makes sense. But what if you took the whole strip, maybe I can draw this up above it. If I scroll up just a bit to give myself some room, what if you took the whole strip area and you minused off something a bit bigger than this? What if you minused off, it's a straight line straight down rather than curving? Well, you wouldn't be equal to that lower rectangle anymore because it's taken more off than what we did before when we took away this bit. It's taken more off. So what you end up with is not equal. What you end up with is less than the lower rectangle. And I think that's what they're getting at in part 2. So that's what we're going to be saying when we work that out now. We're going to be saying for part 2 that first of all, Sn is equal to the sum of the lower rectangles. I'll point that out. Now, Sn, the sum of the lower rectangles, is less than the actual area from end to end. We know that. The sum of the lower rectangles from end to end. Now, when you work out those lower rectangles, of course, from n to 2n, it's actually starting with n plus 1 as the first ordinate. N plus 1, n plus 2, 1 on root n plus 1, 1 on root n plus 2, all the way up to 1 on root 2n. That's what those lower rectangles would be from n to 2n. So we know that that lower rectangle sum is less than the actual area. And I'm saying that that's less than, sorry, the lower rectangle sum is actually bigger than if you took off, if you went, I'm going to start with a particular strip here, and I'm going to minus off. Now, in the box that's above it, so here's the strip, I'm actually going to minus off more than, I'm going to minus off all of that, the blue. I'm going to minus off the blue triangle from the whole strip. So I'm going to take this whole actual area in each strip and minus off the blue, all right? So the purple minus the blue, and it's smaller than the lower rectangles. I don't know how to describe that, but I would need to explain myself. So I'm going to say that I might try and explain it by saying the difference between the upper and lower rectangle strips averaged out. So I'm going to take the actual area minus the average of, no, the difference, difference minus then half of the difference between the upper and lower rectangles, which is like the purple minus the blue bit for all the strips, not just for one strip. That's less than Sn, which is less than the actual area. All right, so if we work on that, we would say that we've got Sn here. In part 1, we worked out the actual area. I'm just going to grab that now. It's 2 root n root 2 minus 1. And what I've got to do over this side is I've got to find out the actual area, 2 root n root 2 minus 1, minus half of the difference between the upper rectangle sum and the lower rectangle sum. So upper rectangle sum minus lower rectangle sum. All right, so I'm going to go over and work that out now as its own separate little thing. This bit here, I'm just going to work out now. The upper rectangle sum, it starts with 1 on root n and goes up to 1 on root 2n minus 1. So I'm just going to write that down. It goes 1 on root n plus 1 on root n plus 1 plus 1 on root n plus 2, all the way up to 1 on root 2n minus 1. And the lower rectangle sum, so minus, and the lower rectangle sum starts at 1 on root n plus 1. You can see that from the diagram. The lower rectangle sum starts with this height here and that I'm colouring in, so that's 1 on root n plus 1, and they're all times by 1 because they've got a width of 1, so the area of that rectangle is 1 on root n plus 1, and the next one's 1 on root n plus 2, and it goes all the way up to 1 on root 2n. So 1 on root n plus 1 plus 1 on root n plus 2 plus all the way up to 1 on root 2n minus 1 plus 1 on root 2n. All right, so we can see that we get 1 on root n plus 1 on root n plus 1 plus 1 on root n plus 2 plus 1 on root 2n minus 1 minus 1 on root n plus 1 minus 1 on root n plus 2 minus 1 on root 2n minus 1 and minus 1 on root 2n, and you know, that guy and that guy are going to cancel, and that guy are going to cancel, and all the way along that guy and that guy is going to cancel, and finally you're going to be left with 1 on root n minus 1 on root 2n, which is root 2 minus 1 on root 2n. All right, so that's the bit that I've brought an arrow down from in the green. So we really have, if we write that line again, 2 root n root 2 minus 1 minus this stuff I just worked out, root 2 minus 1 on root 2n, is less than the lower rectangle sum, which is less than the actual area. All right. Now, when I look at what they've got, they've turned that into a plus, as you can see in what I've circled in the middle of the page there. They've got plus 1 minus root 2 on root 2n. So I'll just go down and I'll see if that will fix up. I've got 2 root n root 2 minus 1. Now, if I make that a plus, then we've got a minus root 2 plus 1 on root 2n, and that's the same thing. So that works out to be 2 root n root 2 minus 1 plus 1 minus root 2 on root 2n, which is less than the sum they gave us, which is less than 2 root n root 2 minus 1. All right, so that just checking that that's the same thing. 1 minus root 2 on root 2n. Yes, so that's the case. Now they're asking us to try and work out what happens if we try to add up from 1 on 1 million up to 1 on 2 million, going up by units of 1. So we're trying to find out 1 on root 1 million plus 1 on root 1 million, 1 plus so on, all the way up to 1 on root 2 million. Okay, well, we're going to let that be the Sn that's in the middle, right? That's our Sn. And that's going to be in between, and we should just be able to have that at the top of the page here. That's going to be between 2 root 1 million root 2 minus 1, and over here 2 root 1 million root 2 minus 1 plus 1 minus root 2 over root 2 times 1 million, or 2 million. All right, so if I put that on the calculator in the left-hand side and put it on the right-hand side, I must get figures that are fairly close to each other. So let's have a look and see what we get. So we've got 2 times root 1 million, okay, times root 2 minus 1. So that ends up being 2 root a million times root 2 minus 1. Just finding my pen. 28.4271,247. And on this other side, I'll now add onto it 1 minus root 2 divided by square root of 2 million. And I get 828.4268,319, etc. All right, now let's have a look at what the question wants to know without having to add up those million possible sums that they've got written there. Just to 3 decimal places have an estimate of what it would come to. I only had to do 2 calculations in the calculator to show that the sum I was trying to find is in between 828.4268 and 828.4271. So to 3 decimal places, the answer is 828.427 to 3 decimal places. Instead of typing in a million different sums, I just use that inequality that we found, and I only have to type a small amount of information into the calculator, and I can narrow down what the actual value is quite easily to 3 decimal places.